All right, we're back. We're still on page 1 of notes 14 of Calc C, and we're talking about logistic differential equation. It's a topic that like could have been a lot bigger, but it's actually kind of a tiny topic, I would say. But it's probably going to come up. You're going to see it in multiple choice. You might see it in the free response. Like it's going to be on there. So this is the differential equation. So uh, where did it come from? It comes from like observation. Really, I mean, a lot of these sorts of things do. And if you look at it, so this is the differential equation. And now here's the solution. You're going to memorize the solution. But like first, let's look at the differential equation. So we got dy dt, so time is usually our independent variable, is equal to k times y, the quantity 1 minus y times the quantity 1 minus y over L. So first thing that I think when I see this is if y equals 0, then dy dt equals 0. And you're never going to change. You just get a horizontal line, like forever. You're never going to change. You're never going to deviate from that. Same as if y equals L, then dy dt equals 0. And you can just plug it in and see, like L over L is 1, 1 minus 1 is 0, 0 times blah is 0. So if you get y equals 0 or y equals L, you're stuck. You're just on a horizontal line. If y is really small, so, and there's no definition of that, but if y is small, so think about it, if y is really small, like 0.001 or something, like really small relative to L, let's say. So relative to L, then dy dt is approximately, so if y is really small relative to L, then this is like really close to 0. So the whole differential equation is roughly or approximately k times y, which is exponential growth, which is why initially you get that exponential growth. And then as y gets bigger, it deviates from exponential growth, which is why you start to curve back down. So it's the growth is curving down. So that's a big deal. Another thing to notice about this differential equation is actually a quadratic function in y. So that's not a marker. It's a quadratic of y. And the zeros of this differential equation are y equals 0 and y equals L. The vertex is actually going to be at the average of 0 and L, right? Is when y equals L over 2. So your derivative, if you graph it, and I know that I'm writing in like a really funny place, but like I can zoom, and so it's kind of okay for me. If this is y and this is dy dt, so this is weird, right? We're using y as the independent variable, dy dt. T should be the independent variable. So we're saying how the rate of change of y with respect to t, we're graphing that as a function of y, as a function of the population. But if this is L, that's a 4. If that's L, it looks like this, and this is at L over 2. So that's actually going to be a point of inflection, right? Because the derivative has a relative maximum there. So L over 2 is going to be a point of inflection. So a lot of things we thought we knew, we did know. This is the solution. Let's derive it. Honestly, if you're not interested in the derivation, you can probably skip the rest of this video, but I'm going to go for it. And also, I didn't try this ahead of time, so you might be better off skipping it. But we're going to do it. I think I'll probably get it right. I'll get it right in the end. K times y, and then 1 minus y over L. All right, we're going to separate. So dy over y times 1 minus y over L. And then this is the reason that the logistic differential equation is not a part of Calc AB and it is a part of Calc BC. You need partial fractions for this. So if we say we have like a over y plus b over 1 minus y over L is equal to 1 over y times 1 minus y over L. If I let y equal 0, I'll be able to figure out what a is. So a is 1, because y is equal to 0. And if I let y equal L, then I get that b is 1 over L. Okay, so what we're going to do is we want to integrate this. So this becomes, what's my work look like here? I should move that. I'm gonna move my partial fractions over. You probably shouldn't have done it there. I don't know, do as I end up having done, not as I say, I guess. So this becomes the integral of, what am I doing? I'll do dy over y, and then plus 1 over L, the integral of dy over 1 minus y over L. Okay, equals the integral of k dt. Good stuff, good stuff. Okay, natural log of the absolute value of y. This one's a little tricky because if u is equal to this thing, then du is negative 1 over L, so you need an extra negative. So it's going to be negative 1 over L, the natural log, the absolute value of 1 minus y over L gross is equal to, this will be kt plus c. Okay, what can we do? I mean, I can multiply through by L, which I mean is maybe the best thing to do. So sure, let's do that, I think. I don't know. All right, I'm gonna multiply through by L. So I get L, natural log, absolute value of y, minus the natural log of, oh, you know what? This is gone. That L's not even there. Holy cow. All right, get rid of that. Get. This L is not here. There's just negative, right? Because if we make u equal 1 minus y over L, then du is negative 1 over L. We only needed the negative sign because we had the 1 over L. There you go. Okay, so we have this. This seems easier. Because I know where I'm headed, and I was thinking I'm not on the right path. But now I think I am, maybe. All right, we're gonna do, what are we gonna do? We combine, I guess. I'm just gonna make this, should I make it one thing? I think I should. First of all, y is greater than 0. And so since y is greater than 0, I think I don't need to worry about the absolute value. I'm gonna drop them. Like when in doubt, drop your absolute values. That's a really bad piece of advice. Kt plus c. All right, exponentiate. Y over 1 minus y over L is equal to a new value of c e to the kt. All right, if we clean this up, we would get L times y over L minus y equals c e to the kt. So far, so good. All right, now what I'm gonna do is I'm gonna take the reciprocal of everything just to kind of like clean it up. So we're going way up here. I'm gonna pick it up and move it, but I'm gonna write it down here. So I'm taking the reciprocal, so it'll be L minus y over L times y equals, the reciprocal of this is like a little tricky because you get 1 over c e to the kt, right? 1 over c e to the kt. But, so that would look like 1 over c e to the kt. But I can just make 1 over c is like a new constant, and then 1 over e to the kt, I'm going to make e to the negative kt. So this will become a new value of c e to the negative kt. Something that's kind of interesting that you don't talk about enough, probably, you definitely don't if I'm your teacher because I don't talk about it enough, is so k is a parameter. It's not an unknown, it's not an arbitrary constant. It's a parameter. Like, we just don't know what it is, but you can't like multiply k by 5 and just say it's a new value of k, because 5k, k is like 2. We just don't know, right? So it's not an arbitrary constant, so it can't absorb things, which is why we had to make it negative kt when we brought it up. We can't just say like, oh, it's a new value of k. K is an actual number. We just don't happen to know it right now. So that's why we had to do that. And now I'm taking this with me up. Actually, I'm just gonna move it up. I was gonna like copy it, but then I realized, no, do that. All right, break it up. 1 over y minus 1 equals c e to the negative kt. I'm gonna add 1 plus c e to the negative kt. I'm gonna take the reciprocal. I definitely lost L somewhere. Where did you go? Oh, this is 1 over L. Oh. Okay, hold up. Is this salvageable? I mean, anything is salvageable because you can just erase everything. This was 1 over L. What is that? 1 over L. Get 1 over L. 1 over L. I'm going to add that to both sides. 1 over y equals 1 over L. And L is a number that we know. We just don't know it. E to the negative kt. What's happening? You know what? I'm going to go back in time again and make my life easier again. I'm erasing again. This is really authentic to how I run my class, actually. You know, do things ahead of time? Nah, do them live. Let people see the math. L minus y over y. C times L is a new C. But then did I just lose? No, you know what I think I messed up? I think I messed up a 1. No, I don't know what I did. Anyway, this is L over y. This is going to be right. I can feel it. E to the negative kt. Here we go. Add 1. Yeah. How come there's a plus sign here? Get out of there. What do I want to do? Move you back over. There we have it. Negative kt. Thanks for bearing with me here. I'm going to take the reciprocal and get y over L, 1 over 1 plus c e to the negative kt. Like barely 50 false starts. Multiply by L, 1 plus e to the negative kt. All right, now what are we going to do for an initial condition? We're not really given an initial condition. So what I'm going to say is that if y of 0 is just y sub 0, right? Then we would have y sub 0 equals L over 1 plus c, because we're plugging in c e to the 0, but that's just c. So y0, 1 plus c equals L. That's a dangerous c. It looks a lot like an L. So then distribute, you get y0 plus y0 times c equals L, which I thought was a 2 for a second. I'm going to subtract and divide, and I get that c is L minus y0 over y0, which, for the purpose of this, we just rename it as a. And I don't know why. I guess because it's not an arbitrary constant. So this is our solution. What is our solution? Okay, so therefore, the solution is y equals L over 1 plus a e to the negative kt. A is L minus y0 over y0. Woo! I think we got it. Like, I'm pretty 100% sure that this is the equation that I wanted to end up with. Let's go to the box and see if we got that. I think we did. There you go. All right. So that's how you derive it. As I said, you didn't need to watch that. So if you watched it and you were shaking your head the whole time, that's on you, because I told you not to. So anyway, I'll be back in the next video and we'll actually do some problems. So I will see you there.